So in this video, I'm going to go through Pure 1, Chapter 8, Differentiation, and this is section 8.1. And we're looking at the gradient of curves. Now, the gradient of a curve is always changing, unlike the gradient of a straight line graph, which is constant. So if we have a look at this cubic graph, we've got a tangent, and you can see here that the gradient of this tangent, of this straight line, is changing depending on where it is on the curve. You can see at the maximum point it's 0. Here it was a positive gradient, and then as the graph is turning, it is a negative gradient, gets steeper and then less steep, and then it's getting closer to 0 again at the turning point. Let's see if I can make it a 0. No. Okay. So it is definitely a 0 at the minimum point, and then it is becoming positive again and steeper again. So the gradient of curves is represented by the gradient of the tangent to the curve at that specific point. And of course, gradient is the steepness and the slope, and it is equal to the tangent, as we said. Okay, so we're going to look at some examples here. The diagram shows the curve with equation y equals x squared. The tangent t, which is the red line, to the curve at the point 1, 1 is shown. Point A is joined to point P by the chord AP. Now this work is different because this work is different from GCSE. At GCSE, to find the gradient, say, of this point on the curve, you were simply asked to draw a tangent and then work out the gradient of that tangent. But this is not as accurate as picking 2 points on the curve and then finding basically the gradient of the chord. That makes it much more accurate because you're physically picking 2 points and you can do it algebraically. Whereas if you're simply drawing the tangent by hand, you would have noticed at GCSE that many of you would have had different answers, different values, and the exam gave you a range of answers. Whereas now we are picking 2 points on the curve. We know exactly what these 2 points are, and then we use algebra to find the gradient of that chord that connects the 2 points, and that is a good estimate for the gradient of the curve. But it also, the smaller the distance, so if I put P here and calculate that chord, that's going to give me a better estimate of the gradient of the curve. So the smaller the distance between the 2 points, the better. Okay. So the tangent to the curve at 1, 1, and I can pick a nice easy point on there. So the point 2, I'm trying to get something accurate, the point 2, 3. Okay, so 2, 3 is a point on the tangent. So I'm going to go from 1, 1 to 2, 3, and I can use algebra. So 1, 1, 2, 3, and I'm using the formula for the gradient. And that formula, let me make some space here, is y2 minus y1. So the gradient is y2 minus y1 divided by x2 minus x1. It's the distance in y, the vertical distance. So got the vertical distance, that's the horizontal, that's the vertical, and it's the vertical distance divided by the horizontal distance, and that gives us the gradient. Okay, so we've got 3 minus 1 divided by 2 minus 1. So that's a 2 divided by 1, and the gradient is 2. Now we're going to do that, but now it says calculate the gradient of the chord AP when P has, and it gives you different coordinates. So we're imagining that this P is moving different parts of the curve, and we're trying to find the gradient of AP. So A is never changing, A is 1, 1, and I'm going to use that as my x1, y1, and this is going to be my x2, y2. So the gradient here is going to be 4 minus 1, 2 minus 1. So that's 3 over 1. So the gradient is 3. You can see every time you use a different coordinate, it will change. Again, this is x2, y2. And I have got so the gradient 2.25 minus 1 over 1.5 minus 1. So this is 1.25, and this is divided by 0.5. And I'll get my calculator, I'll put that in, 1.25 divided by 0.5, so I'm doubling it, which is 2.5. Okay, so it's changing a bit, it's gone from 2 to 3 to 2.5, and we started with a point 2,3, then 2,4, but then we're moving closer to A, so that point P is shifting, and it's getting closer to A, and then it's getting closer still, because 1.1 is closer, and 1.21 is also closer, so x2, y2. So the gradient is 1.21 minus 1 and 1.1 minus 1. So that's 0.21, and it's divided by 0.1. Again, 0.21 divided by 0.1. And that's 2.1. Right. So I can already sense that the gradient is tending towards this value, which is the value, potentially it could be a 2. Let's have a look. Points are getting closer and closer. A and P are getting closer and closer. 1.0201 minus 1 and 1.01 minus 1. 0.0201 divided by 0.01. So 0.0201 divided by 0.01. Definitely getting closer to 2.01. And then what they've done is they've given you the coordinates algebraically. What they're saying, what they mean here is this: A is 1, 1. This is x1, y1. Well, now x2 is a small distance. H represents a small distance away from 1. So here's point A. H is a very small distance in the x-axis. And of course, because this is the graph of y equals x squared, if x is 1 plus h, y is x squared, so 1 plus h squared. So that's where the y comes from. It's not a random thing, it's connected, because y is connected to the value of x when you substitute it into the equation of the graph. So that's x2 and that's y2. And we do the same, we're comparing it to A. So y2, the gradient, is y2, 1 plus h squared, so I'm just going to write it in a double bracket, minus y1, divided by x2, which is 1 plus h, minus x1, which is 1. I hope you can see straight away, 1 take away 1 is gone. So effectively, I now only have an h that I'm dividing by. I'm then going to multiply the two brackets. And I've got 1 times 1 is 1. And then I've got 1 times h is h, 1 times h is h plus h is 2h. And then h times h is h squared, minus 1 over h. Again, I hope you can see that 1 take away 1 is 0. So what I'm left with is 2h plus h squared, which I'm going to factorize. So I'm going to factorize the h out. H is 2 plus h divided by h. And the h divided by h is gone. So really, the gradient is 2 plus h. 2 plus a very, very, very small distance. And as this distance gets smaller and smaller, this is how we write it, as h tends towards 0. As this distance gets smaller and smaller, the gradient of the curve is going to be simply a 2. And this is actually part of the algebraic proof for differentiation. Now you're not examined on the algebraic proof, but you can watch the video for section 8.2. I'm going to go through this again. You're not examined on it, but it's good to see it again. So part C says, comment on the relationship between your answer to parts A and B. Well, B, this whole thing, shows us that as the distance between A and P gets smaller, the gradient of the chord gets closer and closer to the gradient of the curve at the gradient of the tangent at that point. It's basically getting closer and closer to the actual value of the gradient. So I will write this down, but this is just what they want you to see. The smaller the distance between A and P, the closer, the more accurate the value of the gradient, and it resembles the value of the gradient of the tangent, which is the value of the gradient of the curve at that point. So as P gets closer to A, so as the distance between A and P is smaller, the gradient of the chord AP gets closer to the gradient of the tangent at A. So it gives a more accurate measure of the gradient of the curve. Right, this is not in your textbook, but here's an example, and it says find the gradient of this curve at, and then the gradient of the curve at the minimum and the maximum point. So just a note to say, remember that at the turning points, the gradient is 0 because the tangent is completely horizontal. So the gradient is 0 and the gradient is 0. So always at the turning points the gradient is 0. And then for part B it says find the range of values for x for which the curve is a decreasing function. Decreasing function means that the gradient is negative. So if you look at this, it's basically from the turning point to the other turning point. That is when the function is decreasing. So if we take it from here, and to about there. All of these values of x give us a decreasing function. So this is 0.1, 2, 3, 4, 5, 6, 7, so negative 0.7, all the way to 1.1234. So x is bigger than or equal to, smaller than or equal to, and what did we say? Do we count 4? Yeah, 1.4. So all of these values for x give us a decreasing function. And that is the end of this video.